We're going to shift gears slightly in this section from what we did in the last section where we were just working with radical expressions and transforming them into expressions involving exponents. We're going to be using those ideas, though, in this section, and we are going to be solving radical equations using those ideas that we talked about. So, any radical equation, of course, is just an equation that involves some radical expression. And depending on the situation you're dealing with, your technique is going to change a little bit. So in a situation like this, where we only have one radical expression in our equation, in order to solve it, what we want to do first is isolate that radical expression on one side of the equation. So here, what we need to do to begin with is just to add 5 to both sides of our equation, so that we get the equivalent equation, the square root of x, 4x plus 1 is equal to 5. Now, there we go. Now at this point, what we need to think about is that we're trying to solve for x, and in order to do that, we need to get rid of this square root on the left side of our equation. So the inverse of the square root of something is to square that thing. So what we're going to do here is we're going to square both sides of our equation. The square root, or the square root of something is just the thing. So all we're left with on the left side of our equation is 4x plus 1. When we square 5, of course we get 25. And now we've worked our way down to having a linear equation that's much easier to solve. We don't have to deal with that radical anymore. And so we're just going to solve this as we normally would. We subtract 1 from both sides. We get 4x equals 24. And then divide both sides by 4, and we get x equals 6. So there's our solution. And as usual, it would be an excellent idea to check your answer. So if we plug 6 in for x, we get 4 times 6, which is 24, plus 1 minus 5. And of course, 24 plus 1 is 25, so we've got the square root of 25 minus 5, which is just 5 minus 5, which is 0. So we did that one correctly. Okay, let's try another example. Now here, this equation looks a little bit different from the last one in that it's not written with a radical in it, although technically there is a radical expression involved, because as we learned in the last section, anytime you have a rational exponent, like we do here, that denominator, the 3, tells us that we're actually dealing with a cube root. If you're more comfortable dealing with the radical expressions, you could, of course, transform this equation so that it would be 2 times the cube root of x plus 3 squared equals 8. There's nothing wrong with doing it that way. But I'm going to show you a slightly different way to work with this equation. In this case, just like we did last time, we want to isolate that expression that involves x. So the first thing I'm going to do is divide both sides by 2. So I'll end up with x plus 3 to the 2/3 power, and that's going to be equal to 4. Now, since we're trying to solve for x and I want to get it isolated on one side of our equation, that means we need to undo this 2/3 power here. Now, like I said a second ago, if you wanted to, you could transform this into a radical expression, which is completely fine. But what I'm actually going to do is just leave it the way it is with those exponents. And I'm going to think about, well, what would undo raising something to the 2/3 power? And the answer is raising that thing to the 3/2 power. And of course, whatever I do on the left side of the equation, I also need to do on the right side. Now let's think about why this is going to work. We've talked about the fact that if you have a power raised to a power, then you multiply the 2 powers together. So that means we would want to multiply 2/3 and 3/2. And of course, 2/3 times 3/2 is just 1. So they do cancel each other out. That means at this point, we are left with just x plus 3 on the left side of our equation, and on the right side we have 4 to the 3/2 power. I'm going to leave that alone for just a second and go ahead and finish solving this. Our next step will be to, of course, isolate x by subtracting 3 from both sides. So I'm going to get x equals 4 to the 3/2 power minus 3. Now that looks pretty horrendous. So what we can do at this point is simplify 4 to the 3/2 power. Based on what we talked about in section 6.4, we know that anytime we have a exponential expression whose exponent has a denominator of 2, then that means we're taking a square root. So this is really the square root, change my color, the square root of 4 cubed minus 3. 4 cubed, hopefully we know that by now, that is 4 times 4 times 4, that's 64. So this is really the square root of 64 minus 3. And we know the square root of 64 is 8. So this is 8 minus 3, so our solution is actually 5. And of course, as always, you should plug your answer back in to make sure you've done this correctly. Okay, let's take a look at the next type of situation. Here, we only have one radical expression, that square root of 5x minus 1 on the left side of the equation. But if you'll notice, our variable actually shows up twice. It shows up once underneath the radical, and then once on the right side all by itself. So this is a slightly different situation. Our first goal is going to still be the same. We want to isolate that radical expression. So to do that, I'm going to subtract 3 from both sides, so I'll have x minus 3. And at this point, since we want to get rid of that radical expression, we're going to do exactly what we did before, and we're going to square both sides. So when we do that, on the left side of the equation we get 5x minus 1, and on the right side we have x minus 3 squared. Now what you're going to want to do at this point is go ahead and expand that binomial multiplication. So x minus 3 squared is going to be x squared minus 6x plus 9. Now, hopefully you haven't forgotten everything we learned earlier in the year about quadratics, because they're back. And as we learned earlier this year, anytime you're trying to solve a quadratic equation, what you need to do is collect all of your terms on one side of the equation so that the other side is equal to 0. Okay, so if we collect all of our terms on one side of the equation, we'll have x squared minus 11x plus 8. And that'll be equal to 0. So now you've got that quadratic expression on the left side, and you can solve it using any of the methods that we talked about earlier this year. You could use the quadratic formula here, you could complete the square, or if possible, you could factor. So let's see, are there any factors of 8 that we could combine to get negative 11? And I don't believe there are, so it looks like we're going to be stuck using the quadratic formula. And I just realized that we're not. Hold on just a second. I goofed. Is this the eraser? Yes. This should have been a 10. There we go. That's a little better. So now, let's think. Do we have any pairs of factors of 10 that we could combine to get negative 11? And yes, we can factor this. So we can factor this into x minus 10 and x minus 1, which means our solutions are x equals 10 or x equals 1. Now, anytime you have a formula like this, where you have x showing up in two different positions in the initial equation, what you're going to definitely want to check both of your answers, because it may be that one of your solutions, or possibly even both of your solutions, are actually extraneous, meaning they're not going to be possible. So let's go ahead and see, or make sure that both 10 and 1 work out. So if I plug 10 in for x, we would get the square root of 50 minus 1 plus 3. We want to see if that is actually equal to 10. 50 minus 1 is 49. The square root of 49 is 7. So 7 plus 3 is 10. So that works out. Then if we plug 1 in for x, we get the square root of 5 minus 1 plus 3. We want to know if that is equal to 1. The square root of 5 minus 1 is 2. 2 plus 3 is 5, and 5 is not equal to 1. So 1 is actually not one of our solutions. The only true solution to our equation is 10. Okay, I've got one more example that I want to show you all. And this is an equation where you end up with two radical expressions. In this case, what you want to do is you want to solve for one of your radical expressions. In this case, I'm going to choose to solve for square root of 5x plus 4. And I'm going to move that expression, the square root of x, to the other side of the equation. Now, the next step is going to be similar to what we've already done. I'm going to square both sides of the equation. And when we do that, of course, on the left side, we just get 5x plus 4. On the right side of the equation, we're going to have to FOIL that binomial. So first term would be square root of x times the square root of x. So that's just x. Then we would have, for the inside, we would have 4 times the square root of x. For the outside, we'd have 4 times the square root of x. So that's going to be 8 square root of x. And then our last term is going to be 4 times 4, so that'll be 16. Now what we want to do is collect all of the terms that involve an x on one side of the equation. So we're combining like terms here. So we'll have 4x. If we subtract 16 from both sides, we would get 4x minus 12. That would be equal to 8 square root of x. And at this point, what we want to do is isolate that expression with the square root. So I'm going to write it this way. We'll have the square root of x. I'm going to divide both sides by 8 to do that. So that's 4x minus 12 over 8. And since all of those coefficients 4, 12, and 8 have a factor of 4, we can reduce that. So that would be x minus 3 over 2. We're getting there, even though it might not seem like it. What we're going to do next, actually let me copy down what we've got. We've got the square root of x equals x minus 3 over 2. Our next step then is actually going to be to square this equation one more time. So I'm squaring both sides. When I square the left side, of course the square root of x squared is just x. Then on the right side of our equation, we will have x squared minus 6x plus 9 over 4. If I multiply both sides by 4, we get 4x equals x squared minus 6x plus 9. And guess what? We've got yet another quadratic to work with. So this time it's x squared minus 10x plus 9 equals 0. We want to know if there are factors of 9 that we can combine to get a negative 10. If we want to factor this, oh yes, there are. X minus 9 times x minus 1. So that means that our solutions are 9 and 1. And just like we did on the last example, you would want to check for extraneous solutions. Full disclosure, I'm not going to do that right now because the battery on my iPad is about to die.